All right, our speaker today is Joseph Haymaker. He's going to be talking about cover crop impacts on soil health and crop yields on the eastern shore of Virginia.
Share my screen real quick. Everybody hear me? We're good. Yeah, okay. All right, so some of you may know me or know my father, but I'm a PhD student at Virginia Tech at the Eastern Shore Agricultural Research and Extension Center in Painter, Virginia. Most of my research focuses on cover crops, and soil health, and soil nutrient cycling, and all of that, and how they impact you know. So today my talk is cover crops impact on soil health and crop yields in Eastern Shore, Virginia. All right, so on the Eastern Shore, Virginia, predominantly and pretty common on Eastern Shore, Maryland, we have a lot of low organic matter soils, and tillage process speeds up organic matter degradation, especially in our sandy soils. And we face a lot of problems with nutrient leaching and hard pans. So kind of what we're trying to do with the one main experiment I want to talk about is with this long-term cover crop rotations is see how long it takes to take our intensively tilled soil, which was on the left here, and take it and turn it into a healthy soil like the one on the right. And this is actually one on the right from the neighboring field, about 15, which is just 30 feet away, and it's been no-tilled for about 15 years. And so we're just kind of see like how long it would take to bring some life back to this dead soil by implementing cover crops and conservation practices. And as you can see in the picture, this heavily tilled soil, the water is just not infiltrating whatsoever through it, whereas this healthy soil ran right through it. So you're capturing all that water moisture, not losing any nutrients to run off and soil to run off. And then a similar experiment here, same soils from same field. This soil aggregate stability test. And once again, our no-till soil is much healthier than the soil on the left. Aggregates are much more stable and not breaking apart, and means a lot of organic matter and works holding all that soil together. So cover crops offer potential solutions to all those cover crop or soil health problems and much more, such as preventing erosion, scavenging excess nutrients, and fixing nitrogen, relieving soil compaction, increasing water infiltration and water holding capacity, and increasing soil organic matter. So you see here this legume cover crop, the nodules fixating nitrogen, the radish here penetrating in the tillage roots, breaking up compaction. And then with soil moisture and weed suppression, this versus this, there's nothing here, no biomass on the surface to help conserve the moisture and suppress weed growth. So cover crops can be broken into three main functional groups: grasses like rye, sorghum, Sudan grass, and triticale, which produce high biomass and scavenge nutrients and have a high C to N ratio. And then our legumes like clover, hairy vetch, and cowpea, which fixate nitrogen and have a low C to N ratio. And brassicas like radish and rapeseed, which have deep tap roots that can break up compaction and scavenge nutrients. And then you have your mixes where we mix these different functional groups, multiple species from these groups, and you end up getting a variable biomass and accumulation and C to N ratios. And you can design these to fulfill specific functions that you're looking to accomplish. So my main dissertation project, which I want to talk about first, which is located at the Eastern Shore area in Painter, Virginia. This study has 12 different rotations of various cash and cover crops, and is replicated 4 times, covering a little over 3 acres. And it was established in fall of 2014. And the plots are 12 feet wide, 180 foot long. And you can see them in this aerial photo that was taken with the drone about a week before termination this past spring. So prior to the establishment of these plots, this is what the field looked like. This is actually the neighboring field now. This past year, I took this photo. And the management is tilled multiple times a year for potato and vegetable production, as well as it's one of the main weed management controls methods our farm manager likes to use, which pains us soil scientists. But in regards to the tillage being an effective weed control method, I actually heard a great quote recently. If tillage was the answer to weed control, we would have had the problem solved 100 years ago, because all tillage does is restore the soil and the weed bank in it. So all you're doing is just bring all that back up. So obviously hundreds of years tillage, we still have weed problems. So that's not our main answer to that. So for our study, we have 12 different rotations of various crop and cover crop rotations. This is a chart of our rotations for our study, which are now starting in its 8th year here. And I want to go into a little bit of detail about what each of these rotations are. And just as a little disclaimer, the design of it, I started summer 2020, year 5 of the study. So the design of the rotations I didn't have input into. I would like to see it had a little bit more corn and soybean rotations, but the idea being of having continuous corn rotations, kind of like worst case scenario, let's see what we can actually get, cover crops can actually do. So our first rotation in our control is a conventional till rotation, and all the other rotations in the study are all no-till. But this is kind of a worst case scenario treatment, maintaining heavy tillage in it, and no cover crop, and it's continuous corn. Now, 3 other baseline controls are rotations 2, 6, and 8, which are no-till and have no cover crops. Rotation 2 is a continuous corn, while 6 is a corn soybean rotation, and 8 is a corn wheat soybean rotation. And all the wheat growing and all the rotations of this study are grown for production and not as a cover crop. So our first 5 rotations are all continuous corn, with 1 and 2 being the 2 controls, and 3, 4, and 5 are introducing a straight rye, a straight vetch, or a 9-species cover crop mix, which we refer to as the kitchen sink. I'll go into detail what they are, but it's basically like, all right, let's see if we can throw everything with the kitchen sink at it, and that's how it got its name. And also as a reference here, the white pulp, a PVC pipe in the pictures is 5 foot tall. So it kind of gives you an idea of how tall our biomass is, or cover crops are. And rye is planted at 115 pounds an acre, and vetch planted at 32 pounds an acre. So here's a list of those 9 species in the kitchen sink mix, which consists of various grasses, brassicas, and legumes. And this picture was taken just prior to cover crop termination. And all the cover crops in this study are terminated with herbicides and roller crimp if necessary. But as you can see, we have 3 grass species in this: spring oats, triticale, and cereal rye, and then forage radish, rapeseed brassicas, crimson clover, Austrian winter wheat, and area vetch as our legumes. And also, I would like to note, if anyone has grown vetch or thinking about growing vetch, the one challenge we experienced this past year was effectively terminating with just herbicide alone. For our burn down, we apply a high rate of both Roundup and Liberty, but we still saw very inefficient burn down from it. And I've talked with many farmers and weed scientists about this issue, and come to the conclusion that for an effective vetch termination, when it's late in its flowering stage, we need to apply either paraquat, 2,4-D, and or roller crimp. And we plan on roller crimping next year, and then applying a herbicide burn down afterwards. Hopefully that will, it shouldn't kill it all. Basically where the tire tracks were, it was dead because it ripped the stems, but the rest of it kind of survived. Now with rotation 6 and 8, which are the two baseline, to simulate a more traditional corn and soybean rotations. And then we also having with 8 having production wheat winter 2. But rotation 7, similar or same corn and soybean rotation, but with vetch and rye rotating cover crop, with vetch being prior to corn and rye prior to soybeans. And there's planted at the same rate as the 2 monoculture ones in treatments 3 and 4. Now rotations 9, 10, and 11 are diverse mix rotations that have various cover crop mixes each winter, minus the wheat grown in rotations 9 and 11. Additionally, rotations 9 and 10 have a summer cover crop replacing replacing a cash crop for summer 1, while in summer 2 respectively, for 1 summer, while rotation 11 replaces 2 years of summer cash crops. So what these summer cash crops are, they're high. First one, the tall summer mix, is a high CN ratio cover crop with high biomass producing, and its species are listed on the table on the bottom right. And for these summer mixes, this wooden pole here is 7 foot tall, so it kind of gives you a good representation of how tall this cover crop got and how much biomass we were able to produce with this mix. And then our short summer mix is a low CN mix that has a little bit lower biomass producer than the tall mix, but still produces quite a bit of biomass. And our species, you can see here, we have a lot more soybean and cowpea legumes, which will fixate a lot of nitrogen and put a lot of nitrogen back in the soil. All right, now there are 5 different winter cover crop mixes used in these 3 rotations. The residue maker mix consists of triticale, rapeseed, and hairy vetch. And this mix is in winter 1, rotation 9, and rotation 10, winter 2. And then our N fixer mix, again, is a low CN mix. It consists of spring oats, forage radish, and crimson clover. And this mix is planted in rotations 10, winter 1, and rotation 11, winter 2. And now in our winter year 3, there are 3 different low CN mixes implemented in these rotations. The high N fixer mix in rotation 9 has a high rate of legumes in the mix, while the late bloomers mix in rotation 10 allows for soybean or follows soybeans. So it's planted a little later than the rest of the mixes, which are all planted following corn harvest, which reduces some of our biomass, potential biomass we can get out of it. And then our N cycler mix used in rotation 11 is the same as the N fixer mix, but has a higher rate of radish and clover. And lastly, our final rotation 12 is a long-term perennial mix, which is made up of clover, alfalfa, and orchard grass, and then with corn being grown in summer 3. So this is kind of just thinking, all right, if we're putting in a long-term study, put it in a grass field and see how that, and then every 3 years put it in production and see how that would impact yields. Kind of another control per se. Now the rapeseed and these rapeseed and forage radish that pulled this past spring from different mixes prior to determination this spring, and considering these didn't get planted until October 15th. This past or the year before, which is kind of on the later side of our planting window, we actually got pretty good amount of biomass growth out of them, and I was pleased there. So we've looked at a whole number of different soil health measurements, and so far, continuing to look at more. But one of the main ones we looked at is its impact on cash crop yield, specifically corn is a main focus. Nutrient cycling, cover crop with cover crop biomass and nutrient accumulation, alleviation, soil compaction, soil moisture retention, and then done different biological assessments, and then many more. And I'm going to do some more different things in the future as well. So in looking at this was a spring cover crop biomass production over the first 3 years of the study. In the spring, year one actually had some of our highest biomass numbers overall over the past 8 years of the study. But that's because the cover crops got planted early September 15th, because it's the first year of the study. And while most years they ended up not getting planted until about mid-October. And then another thing to note here in 11, we got this really high amount for this year 3, but pretty low in spring 1. And for spring 1, it was actually a week for production, and then this was a high biomass producing mix. So that's why there's that big difference between those two. And then also in year 2, if you look, it's really low. What occurred there is we had a pretty bad drought, and I think kind of the later planting date as well. So it just really severely limited the our biomass production potential there. And as you kind of would expect, the nutrient analysis from these, looking at spring nitrogen accumulation in this graph, be kind of similar to the previous slide, just on the biomass production. And this is kind of what we saw. All these, this is from all the plots in biomass production. The higher biomass production you get, the more nitrogen you're going to accumulate, and it's pretty linear, nice linear increase. So basically, the more biomass you are able to produce, the more nitrogen you would accumulate. And then also with sulfur accumulation, we kind of saw the same trend as we did with the nitrogen, with it mirroring the biomass production. Now this past spring, what I did is I collected biomass samples from the cover crop plots 3 times, which allowed us to see the amount of biomass production over the course of the spring. And as you can see, there's a rapid growth and increase from late March to late April, which we would expect. Warmer temperatures, you're going to get a lot of fast growth out of that short amount of time. So going back to this chart of the graph, if you say terminate at the 1,000 pounds per acre of say this batch here, and then you could have got 5,000 out of it, you're losing 100 pounds of additional nitrogen that you could have accumulated, which is especially important if you have legume cover crops, because they're fixing nitrogen and not tying it up for your next cash crop like grass cover crops would. Now the grass cover crops, everything they're accumulating, it would just get released later as they can decompose, but because they're a high C to N ratio, but the legumes, they would decompose much faster. And again, going back to this slide, the spring 2021 biomass production. If you look here, have a drastic increase in the wheat biomass production, but this, because we're growing it for production, we top dressed it with 120 pounds nitrogen total, split at 62 applications. And that's kind of why we had this drastic jump, and it outcompeted all the other ones. It's had a lot of nitrogen to do that. So one of the things we're going to expand upon, traditionally we've kind of only focused on carbon and nitrogen content of cover crops, but many farmers and ourselves included have wondered what other nutrients are being accumulated by these different cover crop species and mixes. So starting with samples from spring 2020, and might go back a little farther as well, let's go rerun some old samples, but we're going to have a standard plant tissue nutrient analysis done on all the cover crop biomass samples that we've collected. And in addition to doing this with the cover crop biomass samples from this project, we'll also be processing our on-farm stuff, which I'm going to talk about later, for nutrient analysis, doing the same thing. So we'll have both in research plots and on-farm data. And this is kind of an example of what we're trying to generate, because we haven't got our plant tissue results back. We've kind of created this graph just off the estimate of what the nutrient content of CRI is using this year's biomass data. And you see the amount of nutrient, nitrogen, for example, you're going to accumulate 150 pounds of extra nitrogen that would have been taken up from likely deep within the soil profile and brought up and made available for later cash crop use as they decay. And then here, just thought it was a pretty good comparison of our no-till control versus veg planting. Looking at this, we see some weeds, but it's just not as much moisture there in the soil, much more dry. And compared to our veg plots, which had a lot more moisture retention held in there for seed germination, as well as a lot of biological life. When I pulled it back, you can see a lot of worms. There you go. Worms here and here, and there's all kinds of just biological life, which I did not see when I was checking seed depth in our no-till control. Now I go over some of our impacts of cover crops on corn yield data. I'm mainly going to focus on our two summer year 3. So one good thing about this study, what we do is every third year, every treatment or rotation is in corn. And then what we do is we split plot them into 4 different inside dressing rates. So they all get 55 pounds of nitrogen starter at planting. And then just prior to just prior to side dressing, we divide the main plots into 4 subplots and then apply these different nitrogen rates of 0, 50, 100, and 150 pounds per acre randomized through each plot. And this is what our 2017, our first year 3 data results were. As you can see, our controls for some of our lowest yielding, with our cover crops being some of our highest yielding overall, especially those with legumes, with the main exception being the straight rye, which we kind of would expect, especially with our 0 in side dress rate. It's going to tie up a lot of nitrogen and not provide it to corn that follows, whereas vetch, for example, provide. You can see the difference in our 0 in fertilizer, as well as our mixes here. And then looking at these graphs, same thing, but it's just breaking it down by each treatment. And what this shows is the impact of the different in fertilizer rates on the corn yields by rotation, with rotations 4, which is vetch, 5 or kitchen sink, 7, which was vetch prior to this, but it's a rye vetch rotation. 9, first diverse mix, and 11, diverse mix 3, as well as our perennial mix. There was no significant difference between the side dressing rates. So at 0 pounds to acre and 150 pounds to acre side dressing, there was no statistical difference between those yields. So and it's very important in years like this, if you can get away without having to side dress, or nitrogen is through the roof, it would be a good cost saver. And then looking at 2020 corn yields, we didn't see as much of a drastic difference as we did in 2017 between the crop yields. But again, if you're looking at our 0 inside rate, our legume mixes had about the same as our high at 0 as it did at their highest 150 pounds per acre side dress. And again, looking at the 2020 results of this, we saw no significant difference between the cover crop rotations except for cereal rye, which again, we expected. And so this means, again, that there's no benefit at, of adding additional fertilizer at side dress. And then the one cool thing we did this in 2020 was at the tasseling stage and beginning of the reproductive stage, we flew a drone over the plots, and resulted in this really cool NDVI map, which checks for crop health and looking at infrared. And the you can really see the cover crops impact. So this was all cover crops here, green being much healthier, with our conventional till here and here being much less, had a lot less NDVI values and much less healthy compared to our other ones. And as well with treatment too, you can kind of see it as well. And then this graph just kind of reaffirms what you can visually see on it map, that the conventionally till was our worst, the lowest NDVI values, followed by our no-till control, and then the rest were much higher. And in this picture here, you can see the this was rotation 6, which had no cover, and 11 or 7, same as that rotation, just vetch prior and rye in between there. You can see that the 0 pounds was much more chlorotic looking yellow compared to the 150, while in rotation 7 there was really no visual difference between the two. Now in 2021, now prior to side dress, I took a SPAD reading, which measures chlorophyll content on the corn. And because we applied no starter fertilizer this past year prior to side dressing, it gave us really neat results. You can see our vetch treatments were much higher chlorophyll content, healthier looking compared to the controls, the rye, and even the kitchen snake. Now, some of our soil compaction alleviation, we have here, basically this red line here is 300 PSI, and at 300 PSI, most plant roots cannot penetrate it, and especially our cash crops. So that's kind of the limiting factor there. So if you look at our conventional till, after 10 centimeters, which is like around 4 or 5 inches, wouldn't be able to penetrate past it. Same with our no-till. Now you start adding cover crops, that compaction gets alleviated farther down. And our mixes, especially with the brassicas, which have the deep tap roots, really helps alleviate a lot of that soil compaction. And then when comparing all the cover crop treatments together versus the no-till and the conventional till treatments, you can see that the cover crops get us below that root penetration level here at 300 PSI. And just doing no-till alone, as you can see here, does not solve our compaction issues. One thing I've heard with the advent of no-till, that whole idea was to incorporate cover crops into it, but we kind of got away from that years ago when we first started no-tilling years ago. But you can see the conventional till, kind of expected it would have a little less compaction the first 4 inches or so of it. But as soon as you get to where the implement doesn't go down any farther, you're getting that hard pan compaction from tilling. And so it's, again, your roots aren't going to penetrate past there. You're putting them in a pot, basically. Now we also took bulk density tests, and our diverse mixes here were much higher, and with our conventional till being one of our lowest bulk density, which That's another one of our soil health measurements that we have taken. So we wanted to include these from our 2016 Virginia Ag Expo site. We dug a soil pit, and we measured nutrients throughout the soil profile every 6 inches, all the way down to 24 inches. And there we go. And this, you can kind of see here, if you're looking close, that our potassium, as well as our sulfur, there's very high and very high rates or amounts below 12 inches. But the first 12 inches, medium or very low in the case of sulfur. So these two nutrients, potassium and sulfur, are both highly leachable and leach deeper down in the soil profile and are out of the reach of majority of the cash crop roots, especially when in this situation, a hard pan at 9 inches, like we saw here. So think about it, there's a lot of free nutrients that you've already paid for. Apply these fertilizers, they've already leached down to this deeper soil profile. And if you could find a way to pull them back up, you think that it's free fertilizer. And this is what, one of the potentials with cover crops is. So you can see here, this is a radish root down here, and it goes well into that 24-inch penetrating the soil hard pan and getting deep down there, and then have the ability to pull up a lot of the nutrients, as well as rye can do the same thing. And the other thing is, when not only the roots, the nutrients that these would pull up to the surface to provide to the later cash crop, the holes that will make penetrating through the soil profile, the cash crop roots can later follow those channels through it as the roots of the cover crop decay, and allowing them to reach some of those nutrients and water lower and deeper into the soil profile. And at this past year's Ag Expo site, we again saw low and very low levels of sulfur throughout the whole profile, but this time all the way down to 48 inches. And then between 48 and 60 inches, there was 69 parts per million of sulfur, which many of the deep-rooted cover crop species would be able to potentially access and pull up to the surface and deposit for future cash crops. And just here, these white T's are indicating roots, and you can see that some roots are even getting way down to a meter. But this orange line here was a plow hard pan from years ago, previous tillage. Now, my other project I want to discuss with you, which is the on-farm research I mentioned earlier, is working with the on-farm research team of the Precision Sustainable Agriculture Project, which is a multi-state project with 22 participating states and 233 sites total in 2021. I don't know quite how many sites there are on the Eastern Shore of Maryland, but I know over the past few years there have been many, and including in Somerset and Haymaker and all over Talbot County and Dorchester. And then in Virginia, there were 14 sites total in 2021, which I managed the eastern half of the state, the 7 there, and the other Ph.D. student located at campus managed the western half. And basically, the premise of this study is it's a cover crop versus no cover crop on farm study, where all the management decisions are left up to the farmers, and they are to treat both plots the same for this study. And we were looking at cover crop biomass, its decomposition over the course of the season, soil moisture, and crop yield. And with this project, we were creating 2 reps of cover crop plots and bare plots, which are 300 foot long and double the width of the combine header, because we're utilizing their yield monitor data for some of our yields. Now, what we do is we collect 2 1 meter square samples of biomass from each cover crop rep just prior to cover crop termination and cash crop planting. And pretty much most of our farmers try to plant green or just after cover crop termination. So getting as much biomass production as we possibly can. And what we do with these samples are weighed, and then the two reps are mixed together, and we divide up the biomass into 12 different bags, 10 being mesh decomp bags, which are placed in the field, as you can see here. And then we take our T0 and put it in a paper bag, and we bring those back with us to be dried and processed for the initial biomass calculations, what nutrients were there. And then we go out and retrieve the sets to mesh decomp bags. The first set 14 days after termination, 30, 60, 90, and then our final bag we remove at hand harvest and sensor removal. The sample analysis these go through, in addition to the weights, they're sent off for 3 types of nutrient analysis. First, we'll look at their carbon and nitrogen content is measured, and then to ash, which measures their mineral and content and or inorganic content. And additionally, the initial time 0 sample is also sent off to the University of Georgia for near infrared spectroscopy, which measures the total nitrogen, carbohydrates, cellulose, and lignin contents of the cover crop biomass. But fortunately, I haven't received any of the nutrient analysis data back, so won't be able to share these results. When Megan asked me a while ago to do this, I was like, yeah, I'll have all this data, but no, it hasn't gotten back yet. So this is kind of like the diagram. So after planting, typically at our first decomp bag pickup at day 14, we install the moisture sensors in between the crop rows, and these sensors can transmit their data wirelessly to allow us to receive and record soil moisture data in real time. So you see, you just put the bags within the rows as well as the sensors. And this is kind of the diagram of our sensors. We have one at surface about 2 inches, and we also place our decomposition bag on top of that. Then next one is 10 centimeters, about 4 inches. The other one 40 centimeters, and then 75 centimeters down. And this is kind of what it looks like. You see here with the bare plots, and this was a cover, and this is corn and across the bay in Tappahannock region. And then this other site, which is across the bay, you can kind of see the same thing, just the bags in the field and the way the sensors are laid out. And funniest story about this site was just across the bay, and me being from Eastern Shore, Somerset County specifically, put these data loggers on 12-foot poles. Yep, be plenty high enough, be above the corn. But yeah, I was wrong there. The corn there got about 14, 15 foot tall, and ears were at eye level, about 6 foot tall. And so this picture was taken at the end of May. And when I came back to collect the next bag 30 days later, I realized, oh, I messed up. I forgot to mark my pathway into finding the sensors, and walking through corn that tall trying to find these things took a couple hours, and I was already about 6 o'clock at night and 3 hours from home. So it was a long day. And then also this other plot is actually on the shore. You look at the weed suppression abilities of the cover crops at these plots. Actually, at this site specifically, the farmer told me he actually had to go in and spray way sooner than he would normally, and he wouldn't have done because the weeds weren't bad and the rest of the field. But in these bare plots, the ragweed and the rest of the weeds were terrible, and so I had to go spray them before they got out of hand. So that was kind of one of those. Yeah, it kind of confirms that yes, these do a good job with weed suppression. And then also at this site specifically, it was a last minute addition. So we never actually created our bare plots until May 10th. So really it was more of a really early terminated plot compared to a true no cover crop plot. And we still saw that bad of weed problem in here, but not in our cover plots. So what data I do have that I can share is some of our decomposition rate data. So last year I had 2 sites in the Virginia Beach area. Same farmer, it had cereal rye as a cover crop. We're planting it on the same day via aerial seeding, and both terminated on April 21st. So the only differences between these 2 fields is their planting rates, which were 120 pounds and an acre for UFH and 80 pounds an acre for UCT, as well as the cash crops grown with UCT having corn and UFH having soybeans in 2021, and the opposite normal rotation was grown the prior season in both those fields. So as you can see, the course of the biomass production, it averaged the UFH averaged over 2,000 pounds an acre more compared to UCT for that first 30 days of termination. It kind of drifted off a little bit, be a little closer, but there was about 2,000 pounds more of biomass. And I remember looking back at that in nitrogen accumulation graph, the more biomass, and it's also better for weed suppression and everything. And additionally, this farmer, he didn't plant his beans at UFH until May 15th. So there was a good 3 weeks that if you waited and terminated planting, you would have been able to produce a couple thousand more pounds to acre of biomass, most likely. But his fields were kind of spread out, and he was in the area. I was like, I'm just going to spray it and get it killed. Like I said, all management decisions is up to them, so it's out of my control. And then also at this UCT, they called me and was like, hey, I'm going to terminate my cover crops any day now. So I went down on April 8th and collected biomass samples, but he ended up getting delayed until this a few weeks until April 21st. So I had to go back and recollect all the samples. But plus side is we're able to get the biomass weights from that 2 weeks prior, and he nearly doubled his biomass production in those 2 weeks time. So if he had terminated here, that biomass most likely wouldn't have made it until the end of the growing season. Whereas at this one, it made it all the way through to harvest, and all that biomass there for weed suppression, moisture retention, and works. And then we had 3 sites that had wheat on them. These BZW and QLR were 2 sites from the Tappahannock area, and both were planted within a day of each other following soybeans and drilled at 90 pounds an acre. But QLR had corn this year, so it was terminated at corn planting on April 13th, while the BZW was planting soybeans again. And the wheat cover crop was terminated almost a month later, and you can see the drastic different. And these fields are just down the road from each other, so it's climate, it's not really an issue there. But you can see the major jump in biomass production between those 2, just terminating a month later, and how much longer that residue maintained and stayed there. At the end of this site, there wasn't very much biomass left in those decomposition bags. And then additionally, the OJW site on the Eastern Shore of Virginia was also a back-to-back soybean site, but the wheat was broadcast at 150 pounds an acre, but was 60 pounds more than it was at BZW, but it was planted about a month later. So you can see that it didn't quite, kind of had about the same production. It was planted at 60 pounds more, just because it didn't have that, likely because it didn't have that additional month of growing time in the fall. And lastly, this is kind of what our soil moisture data looks like, and this is from the Eastern Shore site. And as you can see, the cover crop plots in the green line retain much more soil moisture compared to the bare plots overall, minus this one. And if you look at these spikes in the graph here, those were rainfall events. If you look closely, you can see that the cover crops retain that moisture a little bit longer compared to the bare plots. Which, again, proof of concept on the soil moisture data. I haven't got it all back. I just had this, was giving us one graph that's been processed so far. And additionally, in regards to the crop yields, at this site in particular, we did see a 2 bushel per acre increase compared with the bare plots averaging about 51 bushels per acre, and the cover crop plots averaging about 53 bushels per acre of soybeans. And this is the only site I have the combine yield data from at this time. I haven't received it all back from North Carolina State, but this site I rode in the combine with them and we got the weights and everything in person. Now, I do want to share just some different good sources for some more information about cover crops if you're interested. First being from the SARE organization. They have a lot of good resources when it comes to cover crops, and I would say these two are some of our better ones. The first one being the Maintaining Cover Crops Profitability book, which has a lot of detailed information about different species, their advantages, potential disadvantages to each one, and more. And then if you're interested in the economics of cover crops, they had produced a really good technical bulletin a few years ago. It's just a lot of valuable information related to economics of growing cover crops and multiple case studies in it. And then the Northeast Cover Crop Council has developed a great cover crop decision support tool, which is a good resource to learn more about different species using their Cover Crop Explorer tool, and their species selectors tool helps you determine what species would grow well on your farm. And I'll quickly run through kind of the process. But if you go here, there's just Cover Crop Explorer, and basically you can see, click what hardiness zone you're in, and click on more, view more crop details on each one, and it pops up a series of descriptions of the cover crops, what goals they're good at performing at. You see, like rye, for example, is very good at nitrogen scavenging, preventing erosion, and surface compaction, improving soil organic matter. Name a few, and different growth traits, and then likeliness to be weed or good at suppressing weeds, and or potential to be volunteer weed later if not managed and terminated properly, and tolerance to different environmental factors and soil drainage conditions they grow well in. This does this for each cover crop. It's on this tool, and then planting rates and termination methods, effectiveness, and planning and growth windows, and like some additional comments and references. Now, their species selector tool is helpful when it comes to narrowing down which cover crops might be good for you. So they're still developing and expanding upon the capabilities of this tool. And in the future, the platform will host a variety of tools, including cover crop mixture and seeding rate calculators and economics calculators. They're also the same groups doing a nitrogen cover crop nitrogen calculator, but it should be released any day now, but it isn't live as of yesterday. So it's kind of pretty seamlessly, works pretty well. You just click next, you input your field address, which provides you your plant hardiness zone. Because this is a Northeast tool, they don't go to zone 8, which is what we are at a research station. That's why I got this error message for. But all of Lower Maryland, Eastern Shore, Maryland is in zone 7. So this tool will work good for you. And then from the address, it pulls your soil type and drainage class and flooding frequency from USDA Web Soil Survey using the address you entered, as well as climate conditions at your location, which is actually based off the last 5 years of data generated from the PSA project, their weather system. So then next, it will ask you what goals you're looking to accomplish with your cover crops, which is always what you should be asking yourself when determining what cover crop species you want to plant. When this tool allows you to select up to 3 goals, and if you hover over the different goals, it'll give you like a little description of how they determine it and how they rate the different cover crops or the different goals. And for demonstration purposes, I selected nitrogen fixation as a goal, improve soil organic matter, and residue that suppresses summer annual leaves as my 3 goals. Then if you go here, you can click on your calendar view, and you can input what your previous cash crop is, and then your planting to harvest date time, and it will give you a zone here of what when your previous cash crop will be grown in that window, and you can kind of base your decision off what cover crops you might want to plant based off of that. And another tool is Virginia Cover Crop College 101, which is made by Virginia NRCS and Virginia Tech in cooperation. It's hosted on Virginia Tech's website. So you just look up Virginia Cover Crop College, the first thing, and it'll take you to this, and then it'll give you different seasonal niches, functional groups, and species, and their manual, and kind of each one will give you a nice little description about each one, and how well they are in mixes. Like for example, forage radish, it's very good in mixes, but do not put too high of a number. You got to reduce the number a little bit of planting rate because it will outcompete some of its companion crops. And they also have a planting calendar and mix calculator. So it breaks it down by seasonal niche, functional groups, and species. And it's in a Excel sheet. It's pretty easy to use. And then also allow you to calculate it. And it gives you different recommendations of the fraction base. So like I said, the grasses and brassicas, they will outcompete, say, your legumes, which tend to be a weaker competitor. So you need to plant them at a higher rate and reduce your grasses and brassica planting rates. Also, there's another website, Smart Mix, which is produced by Green Cover Seed. It's free to use, but it's really got a very good cover crop calculator for mixes as well. And then if you're looking at using cover crops for weed management, Grow Integrated Weed Management Organization, they have a good information about using cover crops and other weed management controls, and then different concepts. So I encourage you to go look at these sources if you want. Maybe you can share them later if you want to email me. I'll gladly share them, or Sarah, Somerset Extension. I know she has all this information as well. Like to acknowledge these funders. Actually, got to add a little more for my research, and then Bethany Walters, who started the long-term project before me. And you can follow us on Facebook and contact me by email or cell phone, or Dr. Ryder, who's my advisor and director here. I would gladly provide you any information you want to know more. That's it.
All right, thank you, Joey. If we have any questions, you can put them in the chat box, or you can unmute yourself and ask them. And if you have any follow-up questions, like you want to see the slides or anything, just shoot me an email. You can reply to the email that I sent you yesterday or today, and I can get that out to you. And just as a reminder, I will need all of your contact information and your voucher or certification number if you are not officially registered. If you put it on the Zoom registration, then I will have it. But if you did not do a Zoom registration, then I will need that information. All right, somebody has a question. Anything on road cleaners?
Yeah, there's a lot of different companies are making some really good road cleaners now. I'm not an expert in that by any means, but definitely think are essential in using like Martin tillage, Yetters, and some other ones. They have one important thing to have, especially for your vetches and your more viney cover crops, to have the ones that have that blade to cut that off of the row cleaner so it doesn't get wrapped up, because that is a big issue with a lot of your more viney legume cover crops, is wrapping into it. So definitely need to be effective at planning and get good seed establishment and to make your cover crops work for you. You definitely need good row cleaners.
All right, and as another reminder, if you need enough nutrient voucher credits, make sure that if you've not done any of the previous sessions, make sure that you tune in next week and be there for the full hour, just to ensure that you get full credit to get your 2 hours of continuing education for nutrient voucher. Next week is miscanthus. All right. I don't see any other questions coming through. So unless you want to type it, or you can unmute yourself again. If you have any questions about any of the tools that he showed on here, if you're having any difficulty, you can always go to your county ag agent and they can assist you with that. And like you said, if you're on the lower shore, Somerset County ag agent does a ton of work with cover crops too. So she would be able to help you out most definitely. But pretty much any ag agent can help you log into those, help you navigate through those tools and see what'll work for you.
I kind of flew through them because I realized I was running late on time.
That's okay. They got their full, that means they got their full hour in for their credits. I think they count anything over 45 minutes as the hour, but you know, you don't want to be sure. All right, I don't see any questions. If something comes up later, you can email me. I can get you in touch with Joey, whatever, you know, we'll get your questions answered. My email should be pretty easy because I've just sent you 2 over the last 2 days. It's